right. Today, you will see that we've got a very interesting presentation lined up. As you've seen in the usage update over the last week or so, William Miller of MaCT Incorporated has been participating in a number of activities with the National Institute for Standards and Technology, as well as Ramez Gerges out at UCSB, University of California, Santa Barbara, who you have heard on our calls before, has been involved with him in doing some very interesting work on sensors, and we're going to bring all that experience together and be able to take a look and see what William said. He'll give us a little bit of a overview of his ubiquitous computing discussion last week, as well as all the things on the cloud computing that the NIST conference was focused on, and allow us to get brought up to speed on all that. William's been participating as a technology provider for usage for a couple of years now. Ramez might be pushing his third year. You got some people who have some pretty good understanding of how to move data around using usage. And in this case, William's going to be talking a lot about mobility and how usage can fly in there. So because we've got a lot of things, a demo from Ramez and William's presentation, let's just run it right over to you, William, and take it on.
Okay, you can hear me okay?
Yep, you're coming through loud and clear.
Okay, welcome everyone. I'm going to step forward into this. We're going to touch base on the new sensor mesh network and our implementation of the UICDS Linux core and a number of other subjects. I've put together an agenda here which will cover the breadth of everything that Jim just mentioned. We just completed an activity here at the National Institute of Standards in Gaithersburg, Maryland, as Jim mentioned, about cloud computing, and we're going to talk a little bit about the Internet of Things, which maybe many of you have heard about now. I'm going to bring you up to speed on a couple of future events that you're going to possibly want to be aware of, and how first responders will be able to have a voice there. Then we're going to talk a little bit about Wave Relay, which Jim has mentioned, as well as then we're going to do a little demo with our UICDS Linux core out at UCSB. Anyway, this was actually the first slide from my NIST Cloud Computing program, which we held at the National Institute of Standards last week. And we were demonstrating the new joint standard between ISO, IEC, and IEEE called P21451-1-4. That's why we came up with a name called Sensi IoT, because that number was just too big. Anyway, basically the Internet of Things, as you've heard so much about, is kind of driving the whole Internet right now. In fact, social networking, as you've seen, is kind of taking off. It's driving the evolution of the Internet, which we now have abilities to talk to you, the UICDS, via smartphones, etc. But it's going to be even doing more now. And maybe a lot of people are not aware that social media today, which we've used in services like Facebook, Twitter, Google Talk, MSN, Yahoo, Skype, even virtual presentations like we're using right now, usually set up their security session with XMPP. So you've probably used products like the WebEx we're using right now, GoToMeeting, and many others. It's rather transparent. Not everybody's aware of that. Basically, we're going to discuss what's now the next evolution of the Internet. This has kind of been the roadmap that's talked about, what's been happening since the beginning. We're kind of in the middle right now, what's called Web 2.0, where we've traditionally been using web services, using like HTML, to provide many of the services like we're doing right now through the internet. But the next step really is evolving into the use of semantics, which we call 3.0. And this is where we want to be able to integrate in smart devices and new services that will lead to a much more intelligent internet, which probably in another couple of years we'll be talking about Web 3 or 4.0. Sorry. Just for everybody's information, we put together a mind map just kind of just showed the interrelationships between everything that's been considered in the Internet of Things, which is going to integrate various devices, services that we know today. And even though you may feel like it is, but they're not really that intuitive at the moment, but would like them to be, so that when you actually move about within the environment, that you'll be able to interact with those devices and the respective services that they may offer. A little bit about the P21451 standard here. As I said earlier, it's a joint effort between ISO and IEEE, and we are also integrating, which I'll talk about, the unique identification to identify the various things within the Internet of Things. And XMPP has already been recognized by the IETF and the World Wide Web Consortium, and we're working with some new extensions now for the Internet of Things, which I'll not go into a lot of detail, but I will be providing you a lot of information that I believe when you'll be able to download this file later, you'll also be able to, copy some of those URLs and other information. Of course, the XMPP offers an ability of assured interoperability and high scalability, which we've already seen in its wide use of in social media. And of course, it has built-in security capabilities, which has been somewhat problematic to be able to do with many other services that we commonly use today using VPNs. And of course, the technologies themselves are technology agnostic and protocol independent, which we're going to see that really gives us a tremendous advantage to be able to allow internetworking between users, applications, and devices. And not everybody knows that the XMPP standard has been brought about by the XMPP Standards Foundation, which kind of came out of the Jobber Foundation almost 15 years ago. But they're responsible for overseeing the XMPP standard. So the various extensions that are developed have to be approved, by the XMPP Standards Foundation, which you can look at that at the xmpp.org website. Our current standard is being sponsored by Dr. Kang Lee over at NIST, who is chairman of IEEE TC9 Sensor Technology, and also Craig Harmon with QED. He's actually the project editor, who's our interface and liaison into ISO, and he's been involved in the supply chain, and which pretty much represents the largest aspect of the Internet of Things, so the interaction between the supply chain, shipping, and various logistics activities. Just to mention the unique identification, which we know even for what we do with the UICDS, makes use of what's called a JID, which is a Java identifier. And that's going to be further standardized, where that identification is going to become very important, how we identify devices out throughout the Internet, which today we may use just an IP address, but there'll have to be additional information provided. Today, we do use things like RFID. We use that to identify a lot of things that are shipping. We're now using what's known as QR codes, which you see at the bottom of the screen. And we're going to see a lot more use of this kind of information, as part of the Internet of Things. I think some of the things I'm going to mention now are the abilities of cyber defense that the protocol makes use of in using XMPP. I mentioned earlier that since the IoT, I'm really talking about XMPP. It's technology agnostic and protocol independent. And of course, we do make use of transport layer security to encrypt data traffic, which is built into the protocol. And of course, it's firewall friendly, which is very, very useful since we're not having to make use of port 80, which is where a significant number of this exposures are, because it gives access to various parts of the operating system when it's below port 100. And of course, we're using a semantic web 3.0 XML metadata to provide the semantic conversations between the devices and users and applications. And of course, you're going to see that we make use of what's called a service broker, which allows to establish a trust relationship between those users, applications, and devices. And we are also have built in a identity provider capability, so you'll be able to have single sign-on. So hopefully eliminate having to carry around those pages upon pages of logins and passwords. That'd be really nice, wouldn't it? And of course, we can have also digital signing of information. So if we're going to transfer documents, for example, that we can be assured that it's who it says it is. And we're making use of a new capability, which is called Efficient XML Interchange, EXI. There's a new XCP, which is an extension that allows that capability to compress the semantic traffic when sending it in a message. One of the other aspects that I think is important is the fact that when we deploy any of the systems, we're getting what's called metadata isolation, in that the semantic representation between the various devices, users, and applications is in the form of the semantics that have already been, encrypted or digitally signed in such a way that we can feel trust between those endpoints. And it obviously prevents a lot of the things that are commonly found on the internet from being able to penetrate those endpoints by these additional layers of security. I mentioned this earlier, but here's a couple of websites that you'll make use of. And the extensions that I'm going to show you can be found on the xmpp.org website. They're also shown on our sensei-iot.org website as well. This is just a list of what the Internet of Things extensions are for sensor networks. These are relatively new. The ones that are indicating with zeros are still waiting for their number and are still in finalization. But many of the others are already available, and we're constantly posting these on the website as we get through them. A couple of ones I'm going to mention is the one Sensei data, which I'll show you in a moment. But the other one I don't want to forget about, which is going to be coming out very shortly, is the ability to be able to transfer HTTP over XMPP. So you'll be able to set up that XMPP type session and be able to send the actual HTTP protocol traffic. So today, for example, when you're using most websites, you're talking to that website. And in the future, as part of the semantic web, we rather expect that just about everyone will have to have registered with a trusted service broker, and then you'll be able to set up a session with that service. And as you know, a lot of people, when they're using their credit cards, bank accounts, and so on and so forth today with simple login and password, other than they generally change the password and have to make it longer, we still end up having to carry around all those passwords and logins. So I think this is going to be a wonderful new capability that will help us out a lot. And that will be built into some of the capability that we'll discuss today. I'm just going to give you a couple of quick examples. I know this is a little bit of dry type session, but I'm just prepping you for what we're going to show in the next few slides. For those who've been familiar with what we've been doing in the UI CDS, we're exchanging messages to be able to set up sessions, for example, and then exchanging other types of data. For sensors now, we'll be able to do the same thing. The sensor will be pre-registered and provisioned in such a way that once you turn it on, you would be able to be connected to all those others that you've established to be trusted to receive it. If you've used various services today like Skype and Yahoo and so on, you know you can set up trust between various friends that you have. Well, now you're going to be able to trust a device. So we often say that's what it is. Here's a response to that request, for example, where it might have been saying, we want to know where the location of where this particular sensor is and what its particular data is. And it will return that information in this type of form. And this is the semantic representation that we put into the exchange of the traffic. And I just want to point out this is a service-oriented architecture. You know, for those people on the call that aren't familiar with all these terms, I'm sure this would be useful for you to be able to have a few more terms to add to your library of information. But as you can see, this is essentially what we use in the UI CDS, is a service-oriented type capability to be able to pass messaging. Now for sensors, we're going to be able to take various sensor type information from various devices that might be in buildings, homes, embedded into roadways, and will exist in our various types of mobile type devices, including vehicles as well as trucks and so on and so forth. And they would then be able to leverage whatever sensor type capability to a gateway that would be able to support XMPP, and then you would be talking via that to your provisioning server, and then that is what you as the user or an application or another device could interact with. This is kind of the basic approach. I wanted to give you a feel of how we're addressing the problem of scalability, because the Internet of Things literally represents billions and billions and billions of types of devices that we currently have all over the planet. Which you can see on the left, typically we would have done this using a VPN to establish a peer-to-peer link. Well, in the middle you'll see where XMPP makes a big difference in providing an XMPP service. You know, via the service, we can pass that data traffic now off to mobile devices, or we also use that to talk to our identity provider for single sign-on. And as you can see on the right, when we do this in the form of a federated service, now we'd be able to move this to the cloud, where the federated server exists in the Internet. But it can communicate to various other private type systems. If you recall, when we transitioned from the analog phone system, I'm sure there was a lot of noise made that says, why do we need to go digital? Of course, we realized later that we got a lot of additional capability in being able to have call waiting and so on and so forth that we never could have before. But now we're at least looking at that model where we're saying that there's going to be something in the middle that will establish that trust relationship between the endpoints. Here's a kind of a control and data plane diagram, which allows you to see that we can leverage the data traffic from any type of technology. It really doesn't matter whether it was wired or wireless. It's really the reachability to your broker. So if that broker is provided locally, then you'll communicate with that, and then that particular broker would have trusted links established with other brokers, which currently we have that in the UI CDS. We can also do this whether we're talking about tying to the cloud as a public type service or having this provided locally in a private fashion. And of course, you know today you're using things like voice over IP. Voice over IP provides that kind of capability for voice traffic, where we now leverage the internet communications via voice over IP. Well, now we'll be able to do the same thing with sensor data traffic. And this is just kind of showing how we're able to provide that bridging capability with a built-in trust relationship. And for a little more information, you can find this out on our sensi-iot.org website. And of course, I'm chairman of this particular group, so you're welcome to join at any time. Just contact me. I'm going to tell you about a few events here that I want you to become aware of next week, which I'll be sending this announcement out, which I'll copy Jim on this later this afternoon, actually. I was waiting for one last person to get back to me. On April the 9th is called Internet of Things Day. We're going to have a virtual conference that will originate here from Washington, D.C., and this is actually a global activity, which I'm showing you a number of the locations which are in Europe. But this is also occurring in San Francisco, as well as in Canada, as well as Australia. And you can go to the IoTday.org website, for example, and you'll be able to learn more about this. This is, as I say, coming on April the 9th. It'll start about 9 o'clock in the morning, and I'll be sending that notification out, which everyone's welcome to attend. There's no fee other than to just register whenever you get the notification. And I think you'll find this additional information where you can learn about the Internet of Things, as well as such things as data analytics and big data. Maybe you've heard a lot of these terms. And we're going to be talking a little bit about the IPDX right now. I'm just showing you here the global events are occurring throughout the day. Not everybody really has been aware of it. It's really to bring the whole message forward now that devices are exploding all over the planet. There's some 50 billion connected devices out there that we're seeing that are coming onto the market, where everything from temperature information, vibration, pressure, even being able to wear this capability is starting to happen. So now we want to be able to find a way where we can tap into that information to make it useful as part of first response. And one other thing I left in here only because I felt it might have some relevance. Just last month, by the way, the U.S. Department of Transportation has decided that they need to have collision avoidance systems built into all vehicles. And that means that real-time collision avoidance system, which is mandated to be put into all cars by starting in the year 2016, which I guess when I think about it, it's just not that far away. And, of course, we're now seeing in certain parts of the country a lot of electric vehicle recharging systems that are now being deployed, and a lot more growth in the use of electric vehicles. So, again, the U.S. Department of Transportation has been having a number of plug fests to work out the details of leveraging the cloud and mobility. But one of the things I'm hoping we'll be able to do is be able to tap in and be able to take advantage of some of that information so that whenever the car has a problem, for example, it can provide notification to fire or police if they should subscribe to that information. But we're still working through the details, but I think that's going to be very interesting. Another activity I'm going to make you aware of is something that's now been initiated by President Obama. This was started on December 12th of last year and will be demonstrated the second week of June. It's called the Smart America Challenge. And what the activity is to demonstrate the benefit of interconnected cyber-physical systems, including improving safety, sustainability, efficiency, healthcare, so on and so forth. I think you'll hear much more in the news forthcoming about this. But again, the capabilities we're talking about in today's presentation will be shown to the President around the second week of June or so. This is the Federated Cluster Broker, service broker that we'll be demonstrating, which is essentially using the elements that I described earlier, making use of an XMPP server, being able to tie in various devices, various services, and so on and so forth. This particular cloud is currently maintained in Scandinavia, in Stockholm, Sweden, and a lot of our team members are in Europe, which I believe a number of those are now using the UICDS in the UK and other countries, which is good. So hopefully they've been able to join the call today. This is part of to demonstrate unified communications architecture, which one of the things I'll show you now is that will now be able to tie into various feedbacks from the power grid, being able to get information from buildings as well as the utilities as well as homes. And this plays very nicely because as we need to get that information when we enter into these areas, should there be any kind of emergency, we would be able to enable those systems to provide information about particular problems that might exist. So particularly things like structural integrity, I think, is a very important element that first responders could make use of. And of course, as it's integrated into homes, we can get alerts directly from those devices. We don't have to wait for someone to notice that there's been a fire or there's been some other emergency, health emergency, for example. That information is going to be provided to us should we subscribe to that, and obviously provided to trusted individuals who provide those services. And one of the key elements that's coming in our test bed is the ability to tie into different types of systems today, which there's a number of other protocols that are being used for various wireless systems. Some are called like MQTT as well as COAP. A lot of you may not know all these names, but XMPP will be used as one of those common transports. And as you can see in this diagram, which is part of our test bed, Telesandra is a major telecom in Scandinavia who is one of the first to tie in with this capability. They have about 100 million subscribers, so I believe that's going to be useful. Of course, they can be accessed from anywhere on the planet, but last week one of the things that was emphasized, because we had a lot of federal people attending the NIST Cloud Computing Conference, was that at least for the United States, and I'm sure this would be true of many other countries, they want to have that service brokerage located within their own country. Even though we may exchange information between the brokerages upon mutual agreement, we'll have to work out those details. But I think that's a key role that major telecoms can play. And but that isn't to say that third parties who would like to offer particular types of services or systems, that may come about as well. That's one of the major elements that President Obama has been stressing in the Smart America Challenge, is that he'd like to see this generate jobs and new business. And of course, that's would help our economy and so on. And of course, I left this slide in here because we're going to be deploying this as part of the Internet of Things using the Semantic Web 3.0. Okay, I'm now going to talk a little bit about Wave Relay, which is a system that we're now using and have tied into the UICDS, so it can get greater mobility. And I'm going to use this as an example because it was used during Superstorm Sandy in New York City. I guess it's been, a year and a half ago or so, almost 2 now? I guess time's going by so quickly. But during this particular emergency, Wave Relay was called upon to assist. And you can see in the diagram here, the communication systems in New York City was knocked out for some time, and it was very difficult to coordinate various different types of services. And they were able to call upon the use of Wave Relay by deploying it out in along the river and on board various ships in the bay, because they couldn't get coordination. Communication is happening for everyone. And one of the key players was the U.S. Coast Guard, as well as the local police and other first responders in the area. This is some of the deployments which were put on the top of the several buildings. I had showed you earlier here that it was put near the New Jersey Rail, as well as on the U.S. Coast Guard cutter, as well as the cutter Spencer. And they were able to put this up, I guess it was in about 9 hours from the time they were asked to do it. And Okay, this is the picture I was looking for. This is showing a lot of the first responders who were working in response to the disaster during the hurricane. And they've been working very closely with the Coast Guard on this particular activity. One of the built-in capabilities of Wave Relay is that you can use things like Google Earth, in that there's GPS capability built into all the units, so that you can bring it up and you can be monitoring how the communication system is operating. You can see the links between all the various radios. And Wave Relay has the ability to operate in multiple spectrums simultaneously, which is very advantageous. It's also been used by the U.S. military, special forces, as well as a number of other groups, to be able to communicate and pass voice, video information. It now supports extensive multicast capability, so we can have real-time video streaming. And of course, integrating this with sensor capability is particularly useful, because the user can carry around the Wave Relay system, have it communicate back to other systems. As you can see in the diagram, they support a quad radio router, which supports 4 radios simultaneously, as well as MPUs, which are called man-portable units. And a new capability that I'm going to mention here is something called Cloud Relay. And that's where the backhaul now can interface with wired or other wireless systems. If you have access to the internet, then it can set up a multiple VPNs on a backhaul, which would allow you to intercommunicate between various mobile clouds that might be with first responders that are deployed in various parts of the city or in other cities. I don't want to think that we'll have super large disasters, but of course, when you hear of recent events like the activity that just happened in Chile over the last day or so, that was a very large earthquake, and I'm sure they're responding well. But in these situations, like you've had for the Katrina disaster, as well as Fukushima in Japan, these are very, very large disasters that are going to require coordination. They did not have these systems in place at that time. And technology has been changing very rapidly over the last few years. The ability to bring to bear assets that have been developed initially for military use, I think are going to be very, very useful for first responders. And it probably will be, at least in our country, I think, be one of the best places where the Internet of Things will take off and be a very valuable service for the communities. The integration of the IPDX, which uses the UICDS Linux mobile core, can now communicate with the Wave Relay system, and you can also interact with your mobile devices. And of course, the ability to be able to stand up an instant infrastructure whenever there's none at all in this particular case, where it never fails that whenever we've had major disasters, whether it's a snowstorm, a hurricane, or even an earthquake, communication systems go down very rapidly. Power is not often available, sometimes for a week or two. So being able to have these types of systems in place will be very, very important to us. One of the other areas that we're dealing with is to establish what's called a federated cloud sensor network, which I want to welcome everyone within the UICDS community to participate. And it'll be making use of this new semantic standard so that you'll be able to tie in and be able to register what devices that you want to use, or if you need to deploy that, it's ready to go. And I think we're going to look at encouraging people within various communities to, establish these kind of sensor-based systems so that that information is available and you'll be able to tap into it. So in summary, really, the benefits for the first responders will be to establish and maintain communications when existing infrastructure has failed. And the UI/CDX Linux core capabilities obviously provide you a very low-cost type system, high performance, and you'll be able to use it under full mobility if needed with a secure and reliable communications. And the ability to have built-in sensors and that exist into the environment, or whether you need to deploy them during your particular emergency, that's going to be very, very useful, and be able to do that easily. Okay, I'd like to turn it over to Ramis Gurgis, Dr. Ramis Gurgis with UCSB, who we had helped him put in a new UI/CDX Linux core, and he has a very nice presentation at their first test bed. Ramis, could you take over and explain what your test bed was about, please?
Okay, thanks, Bill. My name is Ramis Gurgis, and I manage the first responder test bed at UC Santa Barbara, mainly funded by Caltrans, California Department of Transportation, but we are getting also federal funding as well. So I'm just to quickly, I don't have a presentation, but I have quickly touch on three elements of our test bed, which basically was to use intelligent transportation system technology for both transportation and first responder. After a couple of attempts at different architecture, we adopted the Department of Homeland Security UI/CDS architecture, and we have been testing with the help of Jim and his staff, Windows implementation, and later with collaborating with William, we also tested Linux implementation. I will talk about this a little bit later. So the use of this is mainly our virtual emergency operations center, where we can turn any TMC, Transportation Management Center, into an emergency operations center. One of the issues was what happens if I lose the internet, and what happens if I lose my cloud services. Currently, the state of California, WWC, which is cloud-based, and Google Earth, Caltrans, what we call Caltrans Earth, which is basically Google Earth Enterprise, is also cloud-based as like other services like Spot on Response and so on. So I will talk in the last few minutes about our proposed solution and what we're doing. But I'd like to just very quickly test on the IoT activities that we have. I hope that are dealing with the Internet of Things, only talk about sensors and low power, but just our perspective is IoT actually has two categories. One is the broadband IoT, which is the V2V, the vehicle-to-vehicle or connected vehicle, is one example of it. Maybe the most example in the news right now after NHTSA mandated having the active safety, and the backbone of the V2V is what's called dedicated short-range communication. And the dedicated short-range communication actually came originally from my lab here at UCSB. We supplied the first data to prove that Wi-Fi cannot tolerate the multipass of the channel. We competed with the Japanese standard for narrowband and with Motorola standard for wideband FM, and our approach was selected in 2000 as a basis of the U.S. North America standard, and then became an ISO standard as well. We have been spending the last 15 years refining the set of protocols that not only handle the physical layer, but also goes through all the OSI stack. And based on our activity and based on the FCC allocated spectrum, NHTSA can now mandate active safety. So this is one category of the IoT. Of course, part of this IoT for active safety, have many applications like, improving the GPS accuracy to differentiate between lanes in different cars, including video detection for intersection collision avoidance, and many applications. There's about, maybe 35 type of different application. And if you go to the USDOT site and just Google V2V or IntelliDrive, you'll find lots of information there. The other part of the IoT that we have been experimenting with, and we'll be participating or collaborating with William, hopefully in the Smart America Challenge, is low power sensor. In our case, we have an issue at Caltrans where we use 4 or 5 work zone worker each year. So we came up with a smart zone and smart cone, which basically is a set of traditional cones with a very low power expandable, very low cost sensor that have an array of sensors like temperature, magnetometer, so you can sense cars, C-axis, accelerometer, so you can, if a car hits a cone, and then we have a gateway that basically the sensor tag actually using the co-app, which is a protocol designed for constrained resources like a very low power sensor, and we have a gateway that connect actually the sensor network of the cones to a gateway that communicates alerts to both the work zone workers have similar tag on their hard hats, as well as incoming connected vehicles, a new a generation of vehicles that will have what the VSRC radio. So this is a 2 flavor of the IoT that we have been testing for the last 2.5 years. And as I said, one of our interest is to test the co-app with XMPP for this application. Now, we integrate the whole thing. Before we integrate, one of the other things we collaborate with William is, okay, I have now a sensor that generated an interrupt or calling goes to the web service and find out that there was a car hit a cone. I needed to generate a common alert protocol message that comply with the format and the OIC standards, and then propagate all this to the use of this core. So we did this well, and we have been testing for 6 months now, and we have an array of acoustic sensor, video cameras, cones, smart cones, as well as other sensors like radar, and to test all this with it. Then the last thing I'd like to talk about is how do we resolve the issue of what happens when you lose the internet or the cloud services. And actually, we started looking into this 3 years ago or so, and we came with a solution that's a briefcase size that actually integrate the use of this core. In our implementation, we have one that's integrated in the Windows platform and the other one in the new Linux platform. And there was actually an article by Los Angeles Times on January 16th that alert to the hazard that, with the dependency of Google Maps and first responder on cloud-based services like WebUC and others, that they are under the mercy, if basically if they use the internet connectivity, they are lost, and if they still have the internet, but they lose the cloud because part of the internet. So our solution was basically to come up with what we call hidden, which is a hastily deployed intranet network. And as I said, the node is a briefcase size. It has a couple of embedded platforms, small form factor, that house core, using this core in both Windows and Linux. One implementation of this. And the other one, we have an IPDX, which has a CAP message generator detecting, connecting to the sensor. And then we have our own implementation of the radio, which is compliant with DSRC for vehicle to vehicle at 5.9 gigahertz, which is a variation of the 8211A, but also we can configure it over the air to work with 4.9 gigahertz, which is a frequency used by first responder, CHP in California Highway Patrol. And both of them are licensed spectrum. We also have another implementation on the radio for the intranet, which is to poll our cameras using not the PSMA as we're using the DSRC or the Wi-Fi, but what we call STDMA, which is basically a polling. So there is no competition, there is no collision. I go to my cameras in the disaster area and basically supply the intranet through these radios. We also have the Google Earth Enterprise Portable, which will broadcast the Caltrans Earth, which is basically Google Enterprise multi-layer, which have all the Caltrans resources in a local area. This is not a wide area, but each locality, each district in our case, or sub-district will have its own data populated on Caltrans Earth, and then we can broadcast to our public safety radios at 4.9 gigahertz, broadcast the maps and the resources to all cooperating emergency responders. So this is basically a quick summary of what we have at the first testbed. Brad was supposed to demonstrate acoustic sensor and the CAT, but I'm not sure that he is connected right now to the network. Brad, are you listening?
Yes, I'm here.
Anything to demonstrate, or maybe next time we may be able to show them how the hidden and useless and IPDX and Google Earth and even spot and response work. Do you have anything to share?
Well, sure. What we can do, we have the video that shows the several different screens as this is running, so a person can view it whenever they want to. So if you want to have that available, we can do that.
Can you do it now, or you will provide a link?
Well, I can. If I put it up on the screen, I think there's when you share it, it gets real choppy. So it's really it doesn't show very well.
Brad is where
we can make Brad the presenter.
So go ahead. Okay.
Yeah, we can just make Brad the presenter.
Okay. Brad is at the field, so he doesn't have really good internet connectivity, but it would be great if you can switch to Brad. Thank you.
Sure. Let's give it a try. I think, William, you need to give it up.
Okay, I think I'm presenter.
I took care of it, Jim. Okay, great. Thank you. He's going to share his desktop.
Thanks, Jim. Okay. Let's see. So I'm connected. Let's see. What is this blinking for here? Oh, share your desktop. Okay. Sorry about that. So what we want is we don't want that. We want the Sony camera.
So this is basically the acoustic sensor on East Gate at the roundabout.
And okay, I don't want trying to see another tab here. So what I want to show is Sony camera.
And this is a pan tilt zoom camera with DSP capability, looking at the same area at where the acoustic sensor is pointed. the acoustic sensor live?
Yes, it is live.
Because if you can put pulse, you can see the blobs coming from the acoustic sensor when there is a car.
Okay. Will do. I apologize. There's a little bit of delay in the signal here, but this is what they call the east gate of UCSB campus. These are cars going out of campus on this side over here. If you can see the mouse, these are the lanes coming in, and the acoustic sensor is directly above this camera that you're looking at, and so it's set up so that the first lane here is lane 1, lane 2, lane 3, and lane 4 on the outside. And so I'll bring this up. It should be giving us
so basically, the thing on the right bottom corner of this current window is the signal coming from the acoustic sensor for each of the lanes that Brad was talking about.
Right. And okay, let's do this here. Let me. That's probably why it didn't have a signal. And then let me.
Don't you have any of the screenshots that you can?
Well, oh, yeah, this was okay. I guess I just had to reset it. Sometimes it does that. All right, so now I move this over.
So the red is the high intensity echoes from the acoustic sensor, which this blob basically is the car passing by.
We should see 3 and 4. And it's just the way we had this aligned by the person there from Smart Tech. Lane 4 is this little area here. Lane 3 is this area. So it's really kind of a custom. Depends on the installation, what you can see. Pretty light traffic out there today. Once in a while, a bus will come by, and it makes a pretty big response over here in the acoustic.
So basically, what we collaborated with William and Brad and the test bed is to get the signature from the acoustic sensor to generate the CAP messages, but at the same time take snapshots of the video before and after, so we can correlate the acoustic sensor. So can you explain, Brad, the threshold, the speed threshold, and how you get the snapshot and how you pass it to users?
Yes. So what we have is on another system that is connected to this camera, it's running software that will look for anything that moves. It will take a snapshot. It'll draw a box around the object. It's programmable. It will draw a box, make a picture, and store that in a database. And it's given a reference number and a date timestamp. And then the software from William there, it has a feature that will read the acoustic sensor. You can't see it on the screen, but it will tell you how fast each of these blobs is moving. And what happens when that blob, when that measurement is above a certain threshold, we can program, say 25 miles an hour. If it's 26 or more, it'll generate an incident. I can show
in a CAP, the common alert protocol format.
Right. So here's an example. We have a description here. It's kind of informal. We put indicated to tell that this came from the system. And here's an example. This was 26 miles an hour. Speed limit is 25. And it's just a standard use of this message. And so what we were able to do, in addition to this, on another system, is to read all the incidents out of our use of this core and look for the specific date and time, and look for the speed. Let's see. Do we have any of the other ones that I...
So correlated with the set of images and then create a link, right?
Right. So we correlate the cat message generated by the radar, by the acoustic sensor, and we look at the images that are stored in the database, and we correlate those, and then we go back into the radar acoustic sensor event, and we add a new add an image, add a link to an image, and we have that's what we have on the demonstration video, because it takes several computers that are networked together, and but we got it to work just fine. I think with that foundation, it can be expanded to a lot of other things.
And basically, our RACID is deployed intranet. The briefcase have the video image processing software, as well as the cores, as well as the radios, integrated in one box, basically. But it's basically 4 computers, really. 4 small form factor embedded computers.
That's true.
And so very interesting, poking into the edges of the internet and dragging usage along with you. So very, very nice. Let me see whether anybody has any questions for William or Ranas or Brad, our trio of presenters today. No, you mentioned a video, Brad, if that's available, and post it someplace. If you'd send me a link to it, or if you'd send me the video, we can post it up and be able to share that with people.
Sure.
Absolutely.
And William, you said you've got some information about the upcoming conferences. If you shoot those to me, I'll get them out in the next issue usage update. And anybody with any parting comments before we say thank you to our presenters? Yeah, cool stuff. All 3 of you doing some very, very interesting things. So, William, Ranas, Brad, thank you very much for joining us today and for your continued participation as part of the Usage Technology Group. And you opened our eyes to a few things. I appreciate it very much.
Thanks, Jim.
Thanks, everybody.
Thanks, Jim.
Have a good couple of weeks, and we'll catch up with you on April 17th is our next call. We'll be actually originating that from California, and we'll be broadcasting a special, I believe it'll be a full 3-hour session of a technology look at a number of different technologies that are wrapped around usage being used out in California. So you'll get more information on that shortly. But that should be a good session. Thanks for the excellent show today, guys. Appreciate it.
Bye-bye.
Bye, everybody.
Thanks, Jim.